You are the end of an absurdly long streak of luck. Every single ancestor in your bloodline survived long enough to have a child. Follow that line back far enough, and the odds stop making sense. 2.8 million years ago, in what is now South Africa, something clawed through the skull of a 3-year-old. The marks around the eye sockets don't match a knife, or a rock, or another hominin, they match a beak. Somewhere in the count of near misses that follow is a number no one has ever had to say out loud. The obvious assumption is that humans descend from the strongest, the smartest, the most capable competitors around. Were they? Not exactly. Every person alive descends from whoever happened to survive whatever came next, over and over, for millions of years, with no guarantee attached. Paleontologist Lee Berger spent over a decade proving what killed that South African toddler. He compared the child's skull to monkey skulls pulled from eagle nests on the Ivory Coast. The gouges lined up, a punched-through flap of bone, cuts that matched a beak instead of a jaw. Berger ended up calling it the ultimate 2-million-year-old cold case. The child weighed about 10 kilograms. A crowned eagle can carry off prey 3 times that size. Tracing your own existence back through near misses like this is basically our whole thing. Subscribe to the channel, this is just the first one. Go back about 1.8 million years, and the line runs through something barely 4 feet tall, Homo habilis. They still lived partly in trees, which meant they still fell out of them. Chimpanzees, better climbers by far, usually take one bad fall in a lifetime. There's no reason to think Homo habilis did better. Their diet didn't help. Despite the small frame, they ate a surprising amount of meat, sliced with oversized front teeth and thick jaws. Most of that meat came from scavenging, armed with nothing sharper than a stone flake. One of the cats sharing that landscape was Meganterion, a saber-tooth close to a jaguar in size. Its canines ran nearly 2 centimeters longer than a lion's. Those canines were strikingly fragile. Rather than risk snapping one on bone, Meganterion aimed for soft tissue, the throat or the belly, killing fast and clean. That precision worked out well for the local scavengers. Paleontologist Robert Blumenschein spent years examining bones from Olduvai Gorge, finding carnivore tooth marks layered underneath stone tool cut marks. The pattern suggests Homo habilis usually arrived after the cats had already eaten, left to crack bones open for whatever marrow remained. Not everyone agrees. Some researchers read the same marks as evidence the hominins got there first. Either way, the meal was never a sure thing, and it was rarely anyone's first pick of the carcass. One study of 26 Homo habilis skeletons found an average age at death of around 12. Mortality peaked between ages 10 and 14. The oldest skeleton in the sample made it to 25, which apparently counted as a long life back then. The single unluckiest skeleton in the record belongs to OH7, the original Homo habilis holotype, found by the Leakey team in Tanzania. Its leg bone is covered in deep puncture marks. For years, researchers assumed a crocodile did it. A paleontologist named Jackson Zhao grew up around these fossils, working as a museum curator in Tanzania before starting his PhD. He ran feeding experiments with live crocodiles, comparing their bite patterns to the marks on the fossil bone. Working with Christopher Brochu at Olduvai Gorge, he matched the wounds to a species new to science. In 2010, they named it Crocodilus anthropophagus. In Greek, the name simply means the one who eats people. The same bite pattern shows up on 2 more Homo habilis leg bones from the same site, both juveniles, all 3 clustered around the ankle. Something was ambushing at the water's edge, grabbing whatever came within reach. The other hominins nearby weren't necessarily safer company. In 2023, researcher Brianna Pobiner examined a shin bone from Kenya, 1.45 million years old. 9 cut marks lined up exactly where a butcher would strip out a calf muscle. 2 more marks nearby matched the teeth of a big cat, probably a lion. The cut marks alone don't prove cannibalism. Homo habilis, Homo erectus, and Paranthropus boisei all shared that patch of Kenya at the time. Nobody knows which one the leg bone belonged to, and nobody knows which one held the tool that cut it. If the cutter and the victim were different species, it wasn't cannibalism at all, just one hominin eating another, the way a lion eats an antelope. No skull has ever turned up next to that bone to settle which one it was. Even a full-grown elephant wasn't safe ground. At a site in Orsay, Spain, researchers found hyena tooth marks and stone tool cuts layered on the very same elephant carcass. The other diner was almost certainly Pachyrhocutta brevirostris, a hyena built like a lioness with a skull made for cracking bone. A 2023 study modeled the odds. Early Homo could only hold a carcass by showing up in numbers large enough to chase the hyenas off first. Alone, the elephant was never going to be dinner. The climate could be just as unforgiving as anything with teeth. Around 20,000 years ago, at the height of the last ice age, ice sheets up to 2 miles thick spread across the planet. North America, Europe, and Asia all disappeared under it. Average temperatures ran about 6 degrees Celsius colder than today. Surviving meant hunting mammoths with a sharpened stick. It also meant sharing the landscape with Panthera spelaea, the cave lion, one of the largest cats that ever existed. A minor cut could kill just as easily as a mammoth could, since infections had no cure and no name yet. Long before that cold stretch, the species ran into something worse than claws or ice, a volcano. Around 74,000 years ago, Toba, in Sumatra, produced one of the largest eruptions of the last 2 million years. It hurled out nearly 3,000 cubic kilometers of ash and rock. In 1998, anthropologist Stanley Ambrose proposed that Toba triggered a volcanic winter lasting 6 to 10 years, collapsing food chains worldwide. His argument was that the human population crashed to somewhere between 3 and 10,000 people. For 20 years, that was the accepted story. It has since taken a beating. Archaeological sites in India show stone tools sitting right through the ash layer, with no gap in the record before or after. In 2018, a team led by Curtis Marian of Arizona State University made a discovery. Microscopic shards of Toba's own volcanic glass turned up inside a cave on the South African coast. The site is called Pinnacle Point. The shards turned up in layers packed with stone tools and shellfish, laid down before, during, and after the eruption. Whoever lived there never left, and didn't seem especially bothered. Much later, around 10,000 years ago, the species made a decision that looked like progress and mostly wasn't. Across the Fertile Crescent, groups stopped following the seasons and started farming wheat, barley, and lentils instead. In 1987, biologist Jared Diamond called this the worst mistake in the history of the human race. Bioarchaeologists, studying skeletons from a site called Dixon Mounds, found something blunt. The farmers turned out shorter than their hunter-gatherer ancestors, with worse teeth and more anemia. One early farming village left an especially blunt piece of evidence. Atlit Yam, a Neolithic settlement now submerged off the coast of Haifa, in Israel, was among the first places with confirmed evidence of raising cattle. In 2008, Israel Hershkovitz, of Tel Aviv University, examined 2 skeletons pulled from the seabed. A woman in her mid-20s, buried with an infant. DNA testing confirmed both had died of tuberculosis. At roughly 9,000 years old, the oldest confirmed case on record. The assumption had always been that people caught the disease from their new cattle. The DNA said otherwise. The strain in the mother and child was the human form of the bacterium, not the bovine one. Farming hadn't just made people hungrier and shorter. It may have started handing its own diseases back to the animals. Every threat on that list left a mark that fossils or stone tools still carry: a tooth, a bone, an ash layer. None of them broke the line. The closest call left no mark like that at all. It only shows up in DNA. It reaches back further than any of these stories before the farms, before the ice, before the volcano. It points straight into the deep population that would eventually become every human alive today. How close, exactly, did that population come to disappearing for good? In 2023, a team led by geneticist Yishuan Pan at East China Normal University analyzed genetic data from more than 3,000 living people. Working backward from modern human variation, their model reconstructed population sizes deep in the past. For about 117,000 years, the ancestors of every person alive today may have numbered around 1,280 breeding individuals. That stretch ran from roughly 930,000 to 813,000 years ago. That's not a village. That's a large office building, holding the entire future of your species inside it. Somewhere in that headcount was every ancestor you have. Not a backup line, not a spare. The only one. If you want to know how replaceable you were during that stretch, the honest answer is completely. One bad decade in that office building, and none of this happens. Not this video, not the one who's about to read the description under it. The timing isn't random. It lines up with a real gap in the African and Eurasian fossil record, a stretch where hominin bones simply go quiet. Pan called it the start of a new field in human evolution, one that raises more questions than it answers. Some researchers think the squeeze traces back to a major fork in the family tree. That's the split that eventually produced us, Neanderthals, and Denisovans from one shared ancestor. That link is still just a hypothesis, one number pointing loosely at another. Not everyone is convinced the bottleneck happened at all. A 2024 paper argued the whole signal could be a statistical artifact of the modeling method itself. That's the kind of error that can creep in when deep history gets reconstructed purely from modern DNA. Pan's team pushed back in 2025, rerunning the numbers and standing by the original figure. As of now, the debate is still open, and the stakes are real. If there was no bottleneck, humanity's unusually low genetic diversity still needs an explanation. The Toba story carries the same kind of uncertainty. Human genetic diversity really is unusually low, and the ancestors of every living person really did squeeze through something narrow. The likelier suspect is the older, quieter bottleneck, the one nobody put in a documentary. Toba may just have been bad timing. It landed on a species already living on thin margins for the better part of 1 million years. Prehistory was never really a story. It was one long near miss. Someone came out the other side, every single time. Not the strongest, necessarily. Not the smartest. Just whoever was still standing. Somewhere, at the start of that chain, is a 3-year-old, and a bird that almost ended everything before it began. If that streak is worth thinking about, here's what to do. Subscribe, drop a like, and tell us in the comments which near miss got you.